Hey guys, we have official sign to start our meeting. Welcome to Golang Warsaw 11. Today, because of special foreign guest, everything will be held in English, so get used to it. I'm Edgar Chop from GogoApps, official and only organizer of this meetup. And we got here Max Chechel with code generation in Go, and Mike Kabishev, is that right? Okay. Who will tell us something more about Instrumenting Go application. Both guys are from Juno company working on ride-sharing application. Am I right? Awesome. And we have online streaming by Whitestream. Thanks, Camille. So this meetup will be available on YouTube channel after this meetup. And right now, for spectators who couldn't be with us, so sorry. And I'd like to thank to our sponsors, who are Asaisoft, GDG Warsaw, and of course Juno. And special information for all of you guys. You can order refreshments and snacks and everything using password Golang or Meetup. And right now, a word from guest and
Oh, hello. I'm the girl. I brought them here. And just a very quick introduction on the service and application we are working in. This will give you some context to understand what's going on. So we are like 100 people R&D working on an application called Juno. And this is something working in ride sharing in New York at the moment. And we just recently get in a long-term partnership with Get. And together, Get and Juno, we are like pretty much after Uber, second biggest worldwide ride sharing service. Let's put it this way. And Juno is, it started up in its development exactly 2 years ago. Exactly 1 year ago, it went live in New York. And as for today, we have, I think, like 4.5 million rides, like 450,000 of users, around 30,000
nice.
of drivers. So, like, it's pretty big. It's not just yet another taxi app. And we do everything in Minsk. The whole development is in Minsk, Belarus. And the clients are Kotlin and Swift, that kind of stuff. But the backend, it's 50 people all together. And all the development is in Golang. And all the QA engineering is in Python. So overall, we've got 20 Golang engineers working together on microservice architecture backend with like around 60 microservices. And those two guys are like among our engineering team. We have two more who came today just to support. And yesterday we were in Vilnius Golang meetup, so we just have extended weekend and traveling around. Max usually speaks a lot, like in Russia and everywhere. And Mike just started to speak like a half year ago on meetups. So they are kind of geeky. Try not to fall asleep, but try to stop them every time you need to ask something. Yeah, if you will have any question about like application or business or anything like this, try to reach me during the break. I will tell you just a little bit more about that side. But from the technical perspective, let's hear out the professionals. Okay, thanks.
Thanks. And yeah, I think we can start. And guys, floor is yours.
Okay, thank you for having us here. Everything was said about Juno, but I'm going to talk about code generation techniques that we use. So, by generation, in this talk, I mean a data transformation somehow related to Go. And you can see probably you can see all the kinds of transformation you can do. Regarding data to Go transformation, first thing that comes to mind is probably generation of the API clients and servers. For example, Google uses a special JSON format as a source for their generator of all their clients in all programming languages for all their services. There is also such thing as binary data embedding, and there is a cool tool called bin data that allows you to embed any binary data into your Go executable and serve this static data from your program without maybe even having a file system. There is also several tools that allow you to convert DB schema to some kind of DB clients or ORMs. Go to data transformation is also a thing, and you can, for example, generate documentation from your Go code. You will probably use Go meta-linter. These tools actually runs more than 20 different linters that analyze your Go code and give you recommendations about your Go code. So they actually transform a Go code to some human readable messages. There are also compilers. Go compiler itself transforms Go program into the binary executable. And there is also a cool project called Gopher.js that compiles Go program into the JS program. Also, you can generate different kinds of dependencies and call graphs. When we talk about Go-to-Go transformation, first thing that comes to mind is mocks generation. You can generate implementations of some interfaces and then use these mocks to test your application. Also, you can generate API clients and servers. There is another cool project called Go Architecture that provides you a DSL to describe your service, and then from this DSL you can generate all kinds of clients, for example, command line client to your service, and your service itself stops for the handlers, and also it generates a documentation for you. And this is kind of cool project to start something from scratch. There are also type-based helpers that we have to use because we don't have generics. There are also fast serialization and deserialization tools that generates, for example, JSON marshallers and marshallers for your structures. And for example, FFJSON promises you to be twice as faster as standard Golang JSON marshaller and marshaller, which uses reflection. And also you can generate other kind of helpers from your Go code. We have to talk a little bit about reflection, because same tasks you can actually solve by using reflection, but reflection has some problems. The first problem is that you will lose information about parameters and results of the functions that use reflection, because you have to pass interfaces to such functions, and such functions will return an interfaces. And that forces you to spoil your code with type assertions, and they're basically a good place to make mistakes. And some of these mistakes you'll catch only in runtime. Compiler won't help you. Also, in my opinion, reflection-based code is less readable than the generated code, and reflection is also slow. The problem with reflection is that you have to ask runtime about the type of the variable, and information about this variable should be put to the memory in order for you to be able to read it. And so every time you use reflection, it actually leads to additional memory allocation and therefore deallocation when you don't need any information about this variable anymore. So reflection is slow. So what is GoGenerate? GoGenerate is one of the tools in the Go from the Go tools that finds instructions in your code and run commands that follow GoGenerate instructions. So if you run GoGenerate within your project, you'll see hello world in this case. GoGenerate sets some useful variables to your some useful environment variables that you can use in your generators, like Go file, Go line, Go package, and there are a few others. Another trick with GoGenerate is that if you have a generator that resides within the same repository as your program, then you can run such generator via the go run command. So this allows you to avoid the step of building the generator itself. So instead of building generator, then running GoGenerate, and only then building your program, you can just run GoGenerate and build your program. So you can skip one additional step. GoGenerate can be run recursively by using the standard 3-dot syntax. GoGenerate also understands the build tags, so you can generate some platform-specific code if you need, and you also can hide some generators with the custom build tag. So in this case, for example, echo hello world will be executed only if you pass my tag to GoGenerate command. Another question is that where to place GoGenerate instruction, because there are a few options, right? You can place a GoGenerate instruction near the code that uses the generated code, or you can place GoGenerate instruction near the code that is the source for generated code, or you can place GoGenerate instruction somewhere else. And that's what we do in Juno, because it's really useful to have a special file that just lists all things that you need to generate in order to build your program. So you can just open this file and see what code is generated and what generated code do you need actually to build your project. Another question that might arise is, should generated code to be committed to the VCS like Git? And the answer is yes, because it will allow you to track changes in the generated code. It will also allow you to just git pull and go build. And if you have some clients that actually build your code, then the only thing that they need is the contents of your Git repository. They maybe won't even have the tools that you use to generate the code. So you have to put your generated code into the VCS. And it also speeds up the build process. For example, it can be crucial on CI stands where you build your project again and again and again, so it will save time if you use some heavy generators. While writing generators, I developed 5 simple rules. And the first and most important one is that you have to put special header in the generated code that indicates that this code was generated automatically. Because otherwise, people will see this code in the pull requests and will send you messages like you can see, and you'll be constantly participating in this kind of dialogues. So in order to avoid this, always play special header that tells people that this code shouldn't be read, read, or modified. Also, you have provide the same output for the same input data, and this is the actually comes from the idea of committing code to VCS, because if your generator will produce working but differently looking code every time, then your colleagues will see diffs in the pull requests all the time. So your generator has to be a function. Same result for the same input data. It's also much easier to generate working code than the perfect code. It's where Pareto principle applies, because you can spend 20% of effort and get 80% of result, and then spend another 80% in order for your code to look beautiful. And your colleagues won't even look at it, so why do you have to do it? Generated code must be formatted with Go font or Go imports tools. And also you can actually write a generator in any programming language. So with that said, let's implement our first generator in Bash. So let's say we have instruction, conditional statement above the line, and we want to make it more clear. So we have to generate this little nifty method in. And this is how generator in Bash can look like. So we have a header, we have a template, we process our generated code through the Go imports command that will format your code and also fix imports. And if you run, if we put our generator into the Go generate instruction, then, for example, for this file, for this project, after we run Go generate, we can get simple and working code, right? We just generated a method in that we can use in our program. We have a problem? Oh, yeah, okay. So you might think that now you can just grab your program for the type declarations, and for each type you found, you can generate this method, right? The problem is that it won't work, because types can be defined in different ways, right? There are 2 examples of how type can be defined. And also type definitions can be commented. And they also can be commented in 2 ways. So actually the task of finding type declarations is not that easy task actually. And another thing is static analysis. Let's say we have this type, which is the alias for the int slice, and we found this type and we generated this code. And does anybody know what's the problem with this code? So we have this type and we have this code. generated for this type. Once again. Okay, and what's the problem? You're right. This is the correct answer because not all types are comparable in Go. So we actually have to check whether the type that we want this method in to be generated for is comparable. And in order to do that, we have to use different kinds of tools than just Bash. Luckily, Go compiler is written in Go, so there are few useful packages that can help you with working with the Go code. And the first package is GoST. GoST contains all the types describing all the possible nodes in the abstract syntax tree in your Go program. So basically, AST node is the reference to some position in your code. It has start position, end position, and it also has some special attributes for specific types of the nodes in the abstract syntax tree. Go parser has some functions for parsing individual files and directories. Go types contains all the types describing all types that you can meet in the Go program. Go printer can help you with printing out an AST node in human readable format. And it can be useful when you write linters, when you need to generate some message and refer to some, for example, line in your code or particular snippet in your code. Also, there is a really powerful package loader that loads complete packages and programs with all their transitive dependencies. And what's more important is that it creates mappings from the abstract syntax tree nodes to the types description, to the Go types. And there's also imports package that we used on the slide before, and the Go imports command is also accessible as a package, so you can use it in order to format generated code within the Go program. This is how Go types type interface look like. It has two methods. String method just returns type name in the human readable format with the full import path of the package where the type is defined and the type name itself. And some types also have underlying method which returns the underlying type for this type. For example, my struct type is the name type, and this name type has underlying type of struct. But anonymous struct below has type struct type. And struct type has fields attribute that is the slice of the all attributes of the struct. And let's come back to our problem. We have to find whether the type is comparable or not. And this is how the function can look like. So if we found a slice or a map, then we return a false, because in Go, slices or maps are not comparable types. And if we found an array, then we have to check if the elements of this array are comparable. So we run this function recursively. Also, if it's the name type, then we check underlying type of this name type. And if we found a struct, then we have to check all the fields in this struct. So this is the function that answers the question whether the type is comparable or not. And this is the little snippet that from the generator. So we are loading the package, and for every file in this package we run a visitor, and the visitor, what visitor does is it takes an AST node as a parameter and returns a visitor if you need to walk through all the children of this node. So in our case, we are looking for the type specifications. So we're checking that the node is actually a type specification, and then we check the type for comparability. And all comparable types we put to the found types slice. And then we, in a template, we iterate through all the found types and generate in method for such types. So this is how generics can be implemented by using code generation. And then we just process generated code through the imports and get a well-printed Go code with the imports fixed. I wrote a little package that can help you with writing generators. It has some useful functions, so you can take a look at it. But let's go back to the ground and list the things that we actually generate in Juno. In Juno, we generate clients for all our microservices. We also generate requests validators. We also generate mocks of the interfaces for testing our code. We generate valuer and scanner interface implementations for the enums. Also recently I wrote a generator that parses your code and finding SQL queries, SQL queries, and generate prepared statements for such queries. And then when you execute a query, the DB client that we use checks whether we have a prepared statement generated for this query, and if we do, then we just execute this prepared statement. So it allows you to avoid running prepare command before each query you execute from your Go code. Also, we generate call graphs and documentation and Python stubs for microservices functional tests. What about mocks generation? There is a tool Minimock that we developed, and this tool allows you to generate an implementation for any interface. So for example, for this stringer interface, it will generate you this kind of code. So it generates stringer mock, which implements stringer interface. And the main idea of this Minimock tool is that it uses the idea of first-class functions in Go. So it generates a struct that has a string func field, which type is function, and this and the signature of this function is the same signature of the string method that we have here. So you can actually, and this is implementation of string method. So if you assigned a closure to the string func field, then it will basically just run this function when you execute the string method. And if you don't do it, then it will stop your test and produce the error that your code is calling for something that you haven't mocked yet. And this is another helper function that we usually run with the first statement. And the idea here is that you not only can check if you mock something, but you also can check after your test is done if everything that you mocked was actually executed. So it helps you to keep your tests clean, because sometimes you modify the code and the things that you mock aren't used anymore. So your tests are actually getting bigger and bigger while the code can actually get shorter. So this method helps you to find such things. And this is how the test can look like. So we have we assign to the stringer func field a function that returns hello mock, and then we can pass this stringer mock to our service as a dependency. Another way of mocking is so also you can use minimock as a builder. So here we use a special return method, and it is helpful when your code doesn't care about input parameters. So in our case, string function doesn't even have input parameters, so we can use a builder. And the builders are actually very convenient when you have table tests. So when you have a table test, it's really convenient to mock everything you need in one instruction rather than having different functions mocked separately. So another thing that we do is request validation, and we generate validators for requests and requests to that go to our microservices. And what this generator does is processes validate inline tag of the structs, of the request structs, and it generates Go code that can help you to check for the strings length, slices length, and whether the field can have default value or not. And also, if the field in your struct has a type that is the alias to the one of the basic types, and there are few constants of this type, then we treat this type as an enum and check if the field has the value that is listed in one of these constants. And this is how generated code, this is the piece of generated code. So our validator always generates an unexportable validate method. And if in your code you have exportable validate method, then it doesn't generate it. But if you don't, it will generate your exportable version of validate function. And this approach allows you to have some simple checks that are generated automatically, and you can have more complicated checks around it. So you can call validate method with small v in the beginning of your validator or at the end of your validator if you want. Another thing is generating of the clients for all our microservices. We use Nets IO as a message broker and the simple queue service as a persistent queue. So what we do is generate for every handler that we have in the microservice, we generate few helper methods. And what we do is find add handler function in our code. And what this function does is it registers a handler for a specific message type. So this is how handler registration look like, and this is the handler itself, fire event. And for every handler, we find a signature with its name, parameters, and results that handler returns, and generate an interface of the microservice, copy parameters and results of the handlers to the client package. Also, we copy constants of the types used in params or results. And using mini-mock that I was mentioning before, we generate a mock for the microservice. So our client contains everything for other microservices to use, including the mock for testing. So in the tests of the other microservices, you can use this generated mock, and you don't have to generate it every time you need to write a test. And for in our framework, it's the client who decide how the handler should be called. And there are a few ways of calling handlers in the other microservice. One way is to issue a sync call via nuts, or you can issue an asynchronous call with the delivery confirmation. You can also just fire and forget with publish helper, and you can put put request to the other microservice in the SQS, or you can even issue a delayed request to the microservice. So we implement handler only once, and then we generate few helpers for client to decide how this handler should be called. And there will be an example of Chan method that we generate on the next slide. It's the one of the helper methods that we generate. So it returns you a channel that will be populated with the response once request is done, and this helper allows you to, for example, issue requests to several microservices. In your program, in your project, you can have the same pattern, and in order for not repeating ourselves, we generate these helpers. I counted that for every handler, we generate about 300 lines of the code. So in this example, for actually a 7-line handler, we generate 300 lines of helpers. Also, sometimes we generate call graphs that can be used to look at your system as a whole from the architectural perspective. Also, such graphs can help you to estimate refactoring services in your system. So how can we generate such graphs? Well, since we use generated clients for all our microservices, then we can find all the calls to the methods of these clients and just record the caller-callee pairs, for example, in CSV format, or we can generate a dot file for the GraphViz tool. And then you can basically have your graph. Also, if you want to do it yourself, you can take this project and just fork it and modify it for your situation and your particular system. And this is how such graphs can look like. In this graph, every dot is the microservice, and each facet is the interaction in between microservices. So we see how microservices are connected. And this is actually a screenshot from the Gephi tool, which is the special tool to analyze the graphs. And this tool allows you to pick any node and see what connection this node has to other nodes. And so you can actually see which microservices connect to other microservices. And I was also experimenting with these graphs and GraphViz. Unfortunately, I don't have a picture here. And what you also can do is, when you're using GraphViz, is to have multiple facets in between the nodes, and each facet can be marked with the method that you call from the other microservice. So you can actually see all the interactions, like all the calls to other microservices, and you can also color the lines, and each color can mean different transport that you use to pass request. And also you can mark the nodes themselves. And I generated a graph one time that uses the nodes color for depicting that database that we use in the microservice. And each facet has special color that marks the transport that we use. And also we have all the functions that we call from the other microservice. But this graph won't just fit on the screen. But just looking at such graph, you can understand almost everything about your system actually. So this is another number. In our code base, about 50% of the code is generated currently. And that's basically it. So maybe you can ask some questions about code generation. Okay. Yeah. Mm-hmm.
Here you go.
So actually, works. But anyway, so I had two questions, but one of them you already answered because I wanted to ask how you generate clients based on what. But do you generate clients for HTTP APIs? Because
No,
the message broking is
not really. We use SQS, as I said, and the NUTS IO. So basically, what our generated clients do is transform this request to the JSON and pass via specific transport. And this transport is associated with the name of the generated helper. We don't use HTTP within our system to have to request.
Internally.
Yeah.
Okay, and the second question is actually, I actually really like the idea with generating the validators, given the existing alternatives that are mostly based on reflection. And my question is,
yeah.
do you
there
have
are some projects based on reflection.
and it's really nice, especially for performance. But do you, how compatible are you with those stuff like Go Validator and?
Well,
the syntax is more or less.
well, we kind of wanted to keep the compatible syntax, but we ended up with the different ideas because Go validate syntax doesn't allow you to have some validations that we wanted to have. For example, when you have some complex type and for example, one of the fields in your request is of this type, then sometime you want to just write a line near this field. I don't know how to explain without showing the code, but sometimes you want to refer to the field that is the field of this value, and so we basically ended with completely different implementation, and we don't use Go validate. We used it for a while, but currently this validator is not compatible.
It's a perfect use case, so it's a it's nice idea.
So you can just check this out. I hope the slides will be also available, and it's a really well documented project, so you can just look at it and maybe even use it.
Thanks.
Okay, guys, other questions? Anyone? You have unique opportunity to ask our guest. Okay, awesome.
And you have all generated code committed into a
Yes.
repository. And how do you solve problem of consistency of this generated code with source base? Because as a developer, I can change something in source files, not in the generator itself, and
Forget to generate.
forget to generate.
Yes. So we have a functional tests, and even if you forgot to generate the code, all the interactions in between our microservices covered with the contracts. So actually, if you have same contract, it doesn't matter what version of the generated code you use. If it produces same request and same response, for example, then you just don't care. And so we rely on the tests that we have.
Listen.
Okay, guys. Anyone? Okay, so many thanks for this presentation. Yep,
Okay.
and please welcome second speaker. I think that break will not be necessary here. Am I right? 5 minutes? Okay, so I'll break for a cigarette or whatever, and see you in 5 minutes.
Yeah, sure.
Mike, I got you, Mike, and you got your own.
Okay.
Camille, can we start? Okay. Hello, guys. Welcome to the second part of our Golang meetup. Now we have Mike with his speech about Go, obviously, and it was like a lunch break rather from a cigarette break, whatever. And Mike, floor is yours. Bring it
Okay,
on.
thank you. Hi. So my name is Mike. I'm software engineer in Juno, as Jane said, and I'm going to talk today about instrumentation in Golang. And before we start, I have a few questions for you. And the first one is, whoever wrote something in Go here? Wonderful. Oh, cool. And so, sorry, it's on. So on the second question, who used Golang in production? Awesome. Who knows? And the third question is, who knows something about instrumentation? What is it? Okay, you can say what?
Like, for example, instrumenting a client with some additional features. I mean, something like that.
Sorry?
Like instrumenting potentially a client, the same way you instrument application with some additional stuff.
Yes, I'm going to talk about some additional stuff. And okay, according to some official description, the instrumentation refers to ability to monitor your application's performance, to diagnose some errors, and in addition, you can write some trace information. And the all instrumentation is implemented as some instructions in your code source. So let's start. Oops. There are some facts about our tech stack. As Jane said, we have mobile applications. We support two major platforms, iOS and Android, and we have separate applications for our riders and drivers. So in total, we have 4 applications. Our backend, we call it internally Spaceship. It consists of about 70 microservices. Primarily, they're written in Go. We have, I think, about 10 services written in Python additional. They are running in hundreds of containers in AWS Cloud, handles thousands of RPS, and all this stuff is created and supported by the team of 40 engineers. So this is the very high-level overview of our architecture. We have HTTP gateway to communicate with our mobile clients. Then when this gateway receives some request, it performs some checks and validation and repack it into our internal message protocol and push into the NATs. Then all our services are listening for incoming requests from NATs, can handle it, can handle that request and publish back some response. And as Max said, we also use Amazon Simple Queue service for some delayed and queue jobs. When you have such complex and great system, it's very easy. When you have a lot of teams, a lot of engineers, every engineer can write service as he wants. He can use some libraries or approaches or whatever he wants. And when you have few services and few engineers, it's ok. But when we have 40 engineers, a lot of services, it can become a big problem when everybody uses, then each service writes logs in different formats or do some basic stuff in different ways. And it's very good way to have some kind of rules which your service have to follow. And the good example of such rules is 12-factor apps manifest. Does anybody know something about it? Oh, who knows? Cool. Who use it? Really? All rules? Cool. We don't do it. So we of course we use some for those who don't know about it. 12-factor apps describes how you have to manage your code base, your dependencies, how you have to configure your services by passing all configuration via environment variables, that your service has to write all logs to standard output, and so on, so on. There are total 12 rules you have to follow. We use some of them, and for some we break. For example, we use files for configuration, because for us it's a little bit easy to use it to configure, because we have internal configuration management tool built by our ops team, and it produces files, and it fits best for our tasks. So let's start from logs. Logs is a fundamental part of any application. It doesn't matter you create some CLI application or web service. Logs shows the progress of execution of application. It helps you to debug in case of some errors or problems in production system. And if you have good logs, it can save a lot of time for you developers and for operations team to investigate some problem and to fix it. When we're talking about logging in Golang, the standard library provides log package. It's quite simple and can be useful in some ways, but we don't use it because there are some disadvantages. First of all, standard package doesn't provide any kind of levels for logging. You can just print something into the log. You can panic or fatal. So we want to have more levels like described in RFC, like trace, debug, info, warn, and so on. Also, standard package can't use any other format except plain text. So the idea is why. So the standard package treats logs is something to be read by human, and so they don't want to add some, for example, JSON formatters or even any other formatters inside. And because it writes logs only in plain text, there is no way to add struct logging in it. But there are a lot of different packages written by community. You can view the list at the link below, and there are some popular loggers. And for example, with Juno we use loggers package. Does anybody use it too? No? What do you guys use for logging? What package do you use? Custom? Okay, cool. So what is struct logging? Does anybody know? What's the idea of it? Structured logging. Cool. What is it? Yeah, sure. So the idea is that you don't log just some string message. You can log some struct consist of few fields. And in this example, you can view the log message which tells us when this event happened, what was the level, what is the request ID for this event, what is the rider ID in our system, driver ID, write ID, so on, so on, so on. And also you can add some environment information about the service name and the host name where this message happened. So we internally in Go, in our source code, we use log context for storing and passing logger between our code handlers and so on. And we have two common functions. The first one is to put context into to put logger into the context, and the second one to retrieve it. Then the new request comes to our service. We create logger based on the base logger and add the field request ID to it. The request ID in our system is just unique ID generated for every request. When they put this logger into the context and pass it to the handler, and when you retrieve logger from context in your handler, you can just write debug something, and the log message will have the request ID set over there. Also, you can retrieve loggers, add some additional information. For example, you perform some checks or made some queries to database. At some moment, you have rider and driver ID, so it's a good idea to put it in the logger to have all this information. This is the overview of our logging infrastructure. So each service is running into the container. It writes all logs to its standard output, which is fetched by file bit, which knows information about environment. It adds information about the service name and the host name, and then proxy all these logs to the Logstash, and the Logstash writes all this stuff to Elasticsearch. And then we use Kibana UI to retrieve logs, to search, and so on. So the Kibana is our the main point where we do some stuff with logs. This is a little conclusion for the logs topic. So the first point is start use some log management system from the very beginning, because it's very easy to avoid it in the beginning. So you can think, oh, I don't want to integrate some things like Logstash, Kibana, and so on. I will just run everything to the files. But when your system grows and you have more and more services, it's very hard to work with these files, because you need to put all data from all instances and all files into the one place to find something. So even if you don't want to integrate such things like log management system, at some moment you have to do it. And there are a few open sourced systems you can use. The first one is the most popular. It's Elasticsearch Logstash Kibana stack. And the second one is Graylog. Also, there are some other systems you can use. The second point is to use structured logging. Because when you don't do it, you can face situation when you have messages in your log that some request comes to a service, then another request comes to a service, and then you have a log message about some error, and you cannot match the error message with the request message, and you can't understand what really happened. You cannot reproduce this situation. So you can add some additional fields from your domain or so on. For example, you can use user ID to retrieve all logs related to this user, or you can use some other fields you want. And also don't enable only errors available in production, because this is common situation when you develop some service. While you're developing, you set the log value to debug because you want to see all logs. But when you deploy to production, you can think, I just want to see only errors. And you can get in the situation when you have only errors message, but you don't understand what happened again. So in our services, I think all services except 2 or 3 writes all messages, including requests, responses, and so on. So we have debug level set into all our messages, or into all our services. So any questions about logs? Do you have questions, guys? Oh, yeah. You can ask if you want. No? No question? So, we track logs for 2 weeks now. We have, I think, about 500 gigabytes per week. So total we have 1 terabyte for 2 weeks at the moment. So any other questions, so we can go on? Okay, let's go on. So the second topic is metrics. Metrics allows you to show performance of your application. Also, it can be useful to detect some impacts of new versions of your applications. And all the store alerting systems are based on some metrics, on some numeric values. What you can measure in our services, there are three base groups of metrics we have. The first one is information about runtime. We measure number of Go routines and threads and tracks the information about memory usage and GC. You can easily get it by the runtime package. There is special method for it, so it's very easy. In all our services, we track the request rate, how long all these requests been handled, and we track the number of errors. And in some services, we use some third-party APIs, or we can use some databases or caches and so on. We call them external resources. We also track information about request rate and duration, errors, and because it's some external resources for us, we track information about connections. So in all clients to databases, in our HTTP client and so on, we have information about the connection pool we have, how many connections are opened, and how many connections are idle at the moment. There are also few options to use as package for metrics. Standard library doesn't provide anything useful except Explorer package. It allows you just to expose any variable to as some HTTP handler in JSON format, but it doesn't have some functionality for some basic counters, for example. In Junior, we use Prometheus client and storage also, but Prometheus client is written the way you can use it just to aggregate some information into your application, and then you can write some another collector and push information not into some third-party storage. For example, I don't know, you can use it with Graphite and so on, because it really has a good API internally. There are two main models the storages can be divided. The first one is storages uses push model. The idea is that your application make some observations and then push each of them to some storage, or even it can aggregate some information into the memory and push the aggregated data to the storage. There are a few open source examples of it. It's Graphite, OpenTSDB, and InfluxDB. And the opposite way is Prometheus pool model, and the example is Prometheus. So the idea is that your application doesn't know anything about the storage. It knows information only about the format storage uses, and it exposes all aggregated data in this format. And at some moment, Prometheus comes to your service and tells, please give me all metrics you have, takes it and puts into its storage. So this is the picture about our monitoring. So each service has HTTP server inside for some technical stuff. We have Prometheus, which comes every 10 seconds to each instance. It scrapes all metrics from each service and put it into its storage. And it also has some functionality for alert managing. So you can write some rules that if requests take more than, I don't know, 100 milliseconds, please notify me in Slack that we have some problem. Such model can help you to avoid collisions with your metric names. Imagine situation when you have some service, you want to count the requests number incoming, and you decided to call this metric request count. you measure it, and then you push it, for example, to graph it. So you push it number 10, then 11, 12, so on, so on, so on. Everything fine until you create another service which uses the same metric name. In this case, they can push the same metric to the storage, and there becomes collision. And you can decide to let's rename this metric to request count service A and request count service B. Then you can avoid collisions, but then you can face problem when you add another instance of service A, because now there are two instances of service A, and you want to track all metrics independently. So Prometheus allows you to do not add some environment information into the metrics. It exposes only the request count at all, and all this information about hosts, service names is located in the Prometheus configuration. Also, in this case, your application doesn't depend on your monitoring system, because in this case, if monitoring system is down, your application doesn't have to make some decision. If in case of some error, I have to retry this operation or not, and so on. When the monitoring system is up, it comes to your service and scrapes all the information. And because of integrated HTTP handler, it's very easy to make local debugging, so you can open this page into your browser and see all the metrics exposed by a service, run something and see what's changed. This is the slide about data model used in Prometheus. So each metric consists of 3 parts. So the first one is the metric name. Then you can add some labels. In this example, there are 3 labels named service, instance, and group. And the third part is the value itself. And the query language allows you to make different queries. For example, you can count all requests, or you can count only requests from the group begin 0. So it provides 4 base types of metrics used widely. It's counter, which only goes up. It's gauge, that is some numeric value which goes up, down, and so on. It's histogram, and summary, which allows you to make observations into the memory and count quantiles for some durations, for example. It's useful. When we use metrics, first of all, we integrate it into our framework, into the RPC layer. We have middlewares both into the server side, into the client side. So it allows us to measure the network lag between when your client sends request with some time taken by network, and you can see situation then your handler from the server side took only 3 milliseconds, but from the client side it take 10 milliseconds. So we have decorators for HTTP clients, which allows us also to measure the number of requests, its duration, errors, and so on. We integrated metrics into all clients for databases, and caches we use. Some of them we forked because there was no way to do it. So also some of them don't expose information about connection pooling, so we made some changes to allow us to retrieve this information. And also we have some metrics for some business events. In our case, or in your cases, it can be number of users or number of some events that, for example, we measure how much does it take to driver to come to the rider, and so on. And there is little example how we decorate some interfaces into the source code. In this example, we create decorator for the reader, which also holds summary. So we create read method, which measures the time, call original reader. Allows us to inject such decorated version of any interface in our code. And we also have generation tool for this stuff, which allows us also to add label with the was the result successful or not. For example, reader can return error, and if it returns error, we can add label that it was failure call, and if there was no error, so there will be a label that this call is successful. Oops, sorry. There has to be slide also about questions about metrics. Do you have any questions? Okay, let's go on. And the last topic is distributed tracing. Does anybody know something about it? Cool, you're good guys. So what is it? Yeah, sure. And what was the idea? What can you solve with distributed tracing? What the problem?
Just match the logs from lots of nodes from lots of computers.
Yeah, it's
Use this correlation ID that you showed us, right?
Sure. So we live in the era of microservices, and even simple requests from the user can spread all over your system. And in this example, it comes to service A, then it calls service B and service C, and service C makes 2 concurrent requests to service D. And when you develop such system, you can add more services, add some logic, and after some moment you can't keep in mind how these requests goes through your system, and you want to have some tool which allows you to trace these requests in your system. And the first company faced with this problem was Google into the 204 so on. They created a system called Dapper. It's not open sourced, but there is a great paper describing its ideas and problems they wanted to solve, and some terminal terms they use. After 8 years, Twitter created their own system, Zipkin, which currently is the most popular tracing system. And also Uber just open sourced their system Jaeger, but they're still migrating from the closed source to open source, and they rewrite some stuff. And I think it's currently in some alpha or beta situation. And when you decide to integrate such system, you have to use API from one of that system, and it can take a lot of time because all systems at some moment had their own APIs, despite that they use some same ideas from the Dapper. And 2 years ago, guys from few companies decided to start a project called Open Tracing, and they decided to create some standard for this distributed tracing, and they wanted to standardize all semantic they use, that they wanted to use same terms. They wanted to create libraries for all popular languages and to support all popular tracers at the moment. And currently Open Tracing supports Go, Java, Python, and some other languages as I know, and it has support for all popular tracers. Does anybody use it? Okay, so let's return to our request. The idea of tracing system is to represent such request to this form. Here we can see the error request as some bar. It has start point, end point, and we can see who calls, who is the caller and who is the caller. Each bar is called span, and the whole spans are called trace. So each span, each bar has some operation name. For example, it can be name of your PC method. For example, it can be get user or something like this. It has start and end timestamps. It can have some key values, code tags. Also, it can hold some events, and there is term called span context. In open tracing, span context is some identifier for your span. The implementation depends on the tracer you use. In Zipkin, this is one implementation, and for example, in Jaeger is another implementation of span context. So, open tracing library provides good API to create some spans. So there are two examples. You can create, first example shows us how to create span with some operation name. You create it, then you can do some stuff, and when this function returns, the defer is called and the span is finished. Also, you can create the child span of another child span of another span. Here we use the same function. We these functions. If there is no context, no span in context, then the new span will be created. And if there is some span there, then the child span will be created. When we're talking about microservice architecture, we need somehow to pass our spans between services. This is called context propagation, and the idea is to put context into the message you pass between services. When the service A starts some span and make call to service B, in addition to payload, it adds the context. In case of HTTP, it can be parsed in headers. Because we don't use HTTP, we use OON protocol. So we just add it to the section called context. And each service independently pushes trace data to some tracing system. If you use HTTP to make some calls, you can use some helpers from Open Tracing library, which allows you to instrument your request. You can add few lines of code, and you can see such picture. So you can see that we have some client which makes some call. It creates the span called HTTP client, and on the server side there are two spans because the client made two requests. The first one is a little bit longer because HTTP internally uses connection pooling, and there was already open connections during the second request. So the white points on the spans is some events happened during these requests. And when you click onto this bar, you can see such history of all events. And here we see that we get connection from the pool. Then we started DNS query. It was done. When we wrote headers, request, and when we receive response. And we can see the timing of each operation. Also, some key values can be attached to span, and also it can be viewed into the UI. When we started integration of Open Tracing, we create roadmap for us, and the first point was to add instrumentation also into our RPC layer to allow us to track the costs of services, to view the graph like Max showed in his presentation. When we decorate and instrument all clients for the external APIs, when we did the same with databases and caches clients, at the moment we had the good picture how our system works. And at the moment you can see some critical paths. You can see that some requests from user takes a lot of time. And when you start adding some new spans to that critical path to understand what's happening inside that. So you can add spans, you can add some additional tags and logs to the existing spans. And I think that's all for the questions, for my talk. It's time to questions. Do you have some questions?
Any questions, guys?
No? Cool.
So, except that open tracing system, wasn't there any system for this metrics you showed us that was on the market that you could buy and just use it? Have you done such a evaluation?
Open tracing is
except that one.
It's just the API.
I mean, for the metrics section when you were talking about the metrics. So, wasn't there any tool that you could buy just and use it out of the box?
For the metrics?
Yeah. So
instead of Prometheus, you mean also? You mean some tools like New Relic, Datadog, and so on, which you add to your code and it automatically.
Yeah, exactly.
I think we didn't think about that because we don't want to expose our data somewhere.
So I mean, there are tools like you download them, want a jar or something, the binary, and then it has some metrics. So I thought there is something maybe in Golang, but from your presentations, I presume there is none.
I don't think there are some similar projects for the Go which allows you to just add some point. Also, you can. There is some kind of such stuff called pprof, which you can add, which you can import into your code base, and it adds some HTTP handlers to your web server, which allows you to to get information about the Go routines are running at the moment, the call stack. You can record the trace of some request, but it's very, very detailed, and it's very low level in compare with open tracing.
Well, you have things like a metrics collector for the Go runtime out of the box if you use a client for Prometheus, for example, but they won't implicitly trace your requests, for example. They will just gather the runtime metrics.
As I know, Prometheus also had some middleware for HTTP handlers, so we can just easily wrap it and use it.
And there's a bunch of exporters for the Java metrics, like for Cassandra and Elastic to the Prometheus itself, so you can use it as a replacement for the proprietary software that you use.
Any other question, guys?
No questions? I have one to you guys. So when we started to integrate Zipkin into our system, the waste problem, when our Zipkin was down, we noticed that there are a lot of running Go routines in our services. There were dozens of thousands of them. And the problem was into the source code of collector in Zipkin. So there is a little bit simplified code from it, but there is some problem here. I'll explain a little bit. So we have for loop, which reads from few channels. The first span C channel is just queue for all spans. The second one is just ticker, which calls send now method internally and the third channel is send C, which makes HTTP call. And if Zipkin is down, then this code causes big problem. Who can explain why? We have a prize for you for the right question. You want to answer? You know the problem?
Me? No, hell no. So you have a prize for the best answer? You should take a try, guys. Oh, we got...
Maybe because you have some retry logic for sending the data, and when you are ticking, you're getting every second new requests to put data there, which all get retried, and they are all getting retried in parallel, and you're just making it worse with every tick.
No.
I would shoot for like infinite block on sending to the channel.
Sorry?
Infinite block on sending to the last channel, right? Because of the...
Yeah, sure. So the problem is then the ticker channel is ticks. There is new go routine send now which just write empty struct into the send channel. You can think it's running concurrently, but in real the reading of send channel is into the same loop. So if you start making external HTTP request, then the whole loop is stopped, and you can receive some new spans from the channel, and everything wait for it, and all our handlers are blocked at the moment, and it was yeah.
So was it the proper answer or not?
Yeah.
It was a proper answer here? He's the winner?
Yeah, he's the winner.
Bravo!
Here's the prize. So this is an explanation.
Whoa.
And at the moment that's all. So any questions left to me? No?
I'll take a look around, and I see nothing,
So
unfortunately.
thank you very much.
Thank you very much. Guys, it was an honor to hosting you here, GogoApps event.
Thank you.
Yeah, and it was awesome. Really nice speech, both of you guys, Mike, Max. And thank you guys for attending this meetup. And we'll see in next month, the last Thursday. So thank you for attending. And now, please find your partner and start networking. Thanks. It was nice to hosting you.